Suppose you are given a unit square and asked to choose a point inside it uniformly at random. What's the probability that the point lies in the left half of the square? Note that in problems with finite number of outcomes, we normally count them to calculate probabilities. But when we deal with infinitely many possibilities, like points inside a square, counting no longer works. Instead, we rely on calculating the area of a region to calculate probabilities. In this case, the left half takes up half the area of the unit square. So, we get 1/2 as the desired solution. In modern probability theory, the concept of area in 2 dimension or volume in 3 dimension is unified under a single idea called measure. Measure extends the notion of counting from finite sets to any arbitrary set. This framework helps us to handle more subtle questions. For instance, consider a modified problem on the unit square. Suppose we draw a line connecting the diagonally opposite corners of the unit square. What's the probability that a randomly chosen point lies exactly on this line? Observe that the area of the line is clearly smaller than the area of the unit square. To narrow things down, we can cover the diagonal with smaller squares. Start with 4 squares of side length 1/4. Together they upper bound the area of the line as 4 times 1/4 square, which is 1/4. If we shrink the size of squares even further and use 8 squares, each of size 1/8, the upper bound reduces to 1/8. In general, with n such squares, the upper bound on area is 1/n. As the upper bound holds true for all n, we can let the n go to infinity. This results in an upper bound of 0. Also, by definition, the area is always greater than 0. So, with these two bounds, we conclude the area of the line as 0. Here's a question. If the area of a line is 0, does that mean it does not exist inside the square? Of course it does. And this is exactly what we call an improbable event or a zero probability event. When we say an event is improbable, it does not mean that the event is impossible. Improbable events are simply those events which have zero measure. So, in theory, improbable events can happen, but in practice, they will not happen almost surely. The key phrase almost surely captures the idea that the event is improbable but not impossible.